vector operations are pretty simple. One is using a scalar to change the size of the vector. Another is adding, and the last is subtracting. These three basic things operate the same way you've already seen them operate in matrices if you've done that unit. But even if you haven't, it's pretty straightforward. So like if u is 3 comma 2, then 3u is just a vector that's 3 times as big but still oriented the same direction. And so you probably already can deduce what the values would be in here. If regular u is 3 comma 2, then 3u would be 9 comma 6. Nothing groundbreaking here. 2v, so that's the same as regular v but twice as big, so instead of -1, it's -2, and instead of 1, it's 2. So then, if you're going to deal with addition and subtraction, so we've done stuff where you've like used vectors and applied them to points to find ending points. We can't do that here because we don't even have a starting point, but we can find the total vector, like what would happen if you added them all together. In other words, if you had a vector that pointed this direction, and another one that pointed this direction, and another one that pointed over here, and another one that pointed over here. Okay, so rather than keeping track of all those points, you can just add them all together and find what the big vector would be that would have moved you from the starting point all the way to the finishing point. That's essentially what we're doing here. So instead of doing 3 individual u's and subtracting out 2 individual v's, we can find the resultant vector of just like all these things put together, and we'll have a big final vector. So the resultant vector of adding 3u and subtracting 2v is going to be 9 minus -2, so that'd be 9 plus 2, so that'd be 11, and 6 minus +2, because we're subtracting again, so that means 4. So the vector 3u minus 2v is 11 comma 4. Straightforward.